This lesson is going to be on sample spaces. The collection of all possible outcomes in an experiment is called the sample space. Now, you've studied outcomes already. An outcome is the result of an action. For example, you might have a die, and you toss the die one time, and the possibilities that you could get are 1, 2, 3, 4, 5, 6. So the possible outcomes are 1, 2, 3, 4, 5, and 6. That's called the sample space. The sample space for flipping a coin, well, you could get a heads or you could get a tails. Those are the two possible outcomes for flipping a coin one time. So that would be the sample space. Now the sample space for flipping a coin 2 times. You can get a head the first time or a tail the first time. The second time you flip it, you could get a heads the first time. If you get a heads the first time, the second time that you flip, you could get a heads again. Or if you got a heads the first time, the second time you flip, you could get a tails. On the other hand, over here, if you've gotten a tails the first time, when you flip it the second time, you could get heads or tails. Once again, the first time you flip it, you can get a heads or a tails. And the second time you flip it, you can get heads or tails. Heads or tails. That's the sample space. The sample space for tossing a coin 3 times. Well, once again, you can get heads or tails on the first time. If you get heads the first time, you can get heads. Marker. If you get heads the first time, you can get heads or tails the second time. If I got heads the first time and heads the second time, then whenever I toss the coin the third time, I can get heads or tails. If I got heads the first time and tails the second time, well, on the third time, I can get heads or tails again. And the same thing for the tails side of it over here. You can get heads or tails the second time, heads or tails here, or heads or tails here. What we've just done is called making a tree diagram. It's called a tree diagram because these are like branches on the tree. Okay? And knowing how to do a tree diagram is essential to being able to come up with sample spaces. Now, when you have a tree diagram and you want to list your sample space, what you can do is like this: heads, heads, heads. So we write, marker. We write heads, heads, heads. Then we go heads, heads, tails. Heads, heads, tails. Then over here we go heads, tails, heads. Heads, tails, heads. And then heads, tails, tails. Heads, tails, tails. We come over to this side and we go tails, heads, heads. Tails, heads, heads. Tails, heads, tails. Tails, heads, tails. Tails, tails, heads. Tails, tails, heads. And finally tails, tails, tails. Tails, tails, tails. And this is our sample space that we made from the tree diagram. So in the sample space there are 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. And if you look up here, on the very bottom you count 1, 2, 3, 4, 5, 6, 7, 8. So that's another way to double check to see if you've got the right amount of outcomes. Okay, let's make a tree diagram and then find the probability of each event. You choose at random from the letters A, B, C, and D, and you roll a number cube once. What are the chances you get an A and a 5? Remember, what you're going to do is list at the top. I tell you what, I'll start you out on this. You list at the top 1, 2, 3, 4, 5, 6. What do you think is going to go underneath each one of them? Yes, A, B, C, or D. Now, you could have, instead of doing it this way, you could have listed at the top A, B, C, D. And then what could you have done? Right, you could have put the numbers 1, 2, 3, 4, 5, 6 underneath each one of them. So I'm going to let you do that. Okay? If you find out what are the chances you'll get an A and a 5. It's your turn. Pause the video, try this, and then come back to me. Alright, so we got the A, the B, the C, and the D at the top. What we could have, let me get a different color marker. What we could have is 1, 2, 3, 4, or 5, or 6. And if I'm really going to make a tree diagram out of this, let's do it this way. Let's spread these out a little bit. Oh, it's not going to let me. So we erase that, and we get our marker again, and we write A way over here, and B here, and C in the middle. Get a different color, and we come over here 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This is our tree diagram. Okay, so now what are the chances of us getting an A and a 5? Well, let's see how many items are in our sample space. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 possible outcomes in our sample space. And the probability, the chances of getting an A and a 5, there's just one right there, are 1 out of 24. Did you get that? Alright, let's make a table to find the sample space for rolling 2 number cubes. We'll write the outcomes as ordered pairs. So, on the first roll, we could get a 1, 2, 3, 4, 5, or 6. On the second roll, we could get a 1, 2, 3, 4, 5, or 6. So if we got a 1 on the first roll, what are the possible outcomes on the second roll? Well, we could get a 1, a 2, a 3, a 4, a 5, or a 6. So we could get 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, or 1, 6. The same thing would work over here, so we go over 2, 2, 2, 2, 2, 2, 3, 3, 3, 3, 3, 3, and 6. So we come back and we put our commas, and then we go 1, 2, 3, 4, 5, 6 on each one of them. 5 and 6. Okay, so now we've got our possible outcomes listed in a sample space there. Now let's go to the next slide here. It says find the probability of rolling at least 1 3. So we come back over here to the other side. How many possible outcomes do we have? We have 1, 2, 3, 4, 5, 4, 5, 6 by 1, 2, 3, 4, 5, 6. So we go 6 times 6. We have 36 possible outcomes. And the question is, find the probability of rolling at least 1 3. So we look through here. Let's do this. There's 1. There's 1. Then we've got all these right here. And then we've got 1 here, and 1 here, and 1 here. So how many is that? Let's see. 1, 2, 3, 4, 5, 6, 7, 8. We've already counted this one. 9, 10, 11. So it's 11 out of 36. You show the sample space and find the number of outcomes. Then find the probability. You roll a number cube once. Remember that's 1 through 6. What is the probability of rolling a number less than 4? Show the sample space. This one's not as complicated as the other one. You've only got one number cube and you're only rolling it once. So write the sample space and then tell me the probability of rolling a number less than 4. Pause the video and get back to me. Okay, so we've got the possible outcomes in the sample space are 1, 2, 3, 4, 5, and 6. And the numbers less than 4 do not include 4, okay? Numbers less than 4 are 1, 2, and 3. So that's 3 numbers out of 6, which gives you 1 out of 2 as the probability of rolling a number less than 4. What is the sample space for tossing 2 coins? This is another way to do it. You can write heads and tails on the top, heads and tails on the side, and then we can get heads, heads, tails, heads, we can get heads, tails, or we can get tails, tails. So find the probability of getting 2 heads. There are 1, 2, 3, 4 possibilities in our sample space. 2 heads, 1 place right here. So that gives us 1 out of 4 is our probability. All right, this is your turn. What is the sample space for tossing 2 coins? We just did this. See if you can remember how to do it. And then find the probability of getting a head first and then a tail. Your turn. Pause the video. Okay, remember we got heads, heads as a possibility, or tails, heads, or heads, tails, or tails, tails. So the probability of getting a head first. Well, here's a head that came first because there's the head. There's a head that came first. Over here the head came second, and there are no heads here. So that's 2 out of 4 or 1 out of 2. We always want to simplify. Suppose you're going to travel on a river and you have 2 choices of boats, a kayak or a rowboat. You can go upstream on 3 smaller streams, to the north, northwest, or northeast. What is the probability, what is the sample space for your journey? Okay, so there are 2 ways that we can go. We can go on a kayak or a rowboat. We can either go north, northwest, or northeast when we take the kayak. If we take the rowboat, we can go north, northwest, or northeast. So the outcome will be kayak north, kayak northwest, kayak northeast, rowboat north, rowboat northwest, or rowboat northeast. What is the probability of selecting a kayak and going directly north? Here we go. Directly north is 1. 1 out of 1, 2, 3, 4, 5, 6. So it's 1 out of 6. Now what we're going to do now is look at this in a different way. In the previous example, there were 2 choices of boats. See, the boats were, here we go, kayak or a rowboat. And there were 3 choices of streams. Whoops, wrong way. North, northwest, or northeast. So there were 2 choices of boats and 3 choices of streams. So all we had to do was go 2 times 3, and that gives us 6 total possible choices. This is called the counting principle. All you got to do is take the number of choices times the number of choices, and you get the total possible choices. The counting principle. Let's look at another example. Using the counting principle, if you can choose a shirt in 5 sizes and 7 colors, then you can choose 5 times 7, or 35 different combinations of sizes and colors. This helps you out because whenever you're doing your sample space, you want to make sure that you have the right number of items in your sample space. So one of the first things you should do is find out how many items you should have, and then when you're finished listing, check the number of items to see if it matches up with what you should have. Alright, using the counting principle, a school has 4 art teachers, 3 music teachers, and 8 history teachers. And how many ways can a student be assigned an art teacher, a music teacher, and a history teacher? It's your turn, so pause the video, try this, and get back to me. Alright, so we have 4 art teachers, 3 music teachers, and 8 history teachers. So we just go 4 times 3 is 12, times 8 is 96. So there were 96 possible outcomes that you could find to where you could have an art teacher, a music teacher, and a history teacher assigned to you. Alright, a spinner has 4 equal sections numbered 1 through 4. You spin it twice. Use the sample space below to find each probability. We got 1, 2, 3, 4 as a possible outcome on the one spinner the first time, and the second time 1, 2, 3, 4. And here are our possible outcomes. Probability of a 1, 2. Well, we've got 1, 2, 3, 4. 1, 2, 3, 4. 4 times 4 is 16 possible outcomes. A 1, 2, there's only one circumstance where you have a 1, 2. There's a 2, 1 there, but that's not the same as 1, 2. So it's 1 out of 16. All right, the probability of 1 and then odd. Well, here's 1, 1, 1, 1. 1 comes first. Odd. 1, 1 is odd. 1 is odd. 2 is even. 3 is odd. So there's 1, 2 chances out of 16. Or 1 out of 8. And the probability of even then odd. Well, here's the evens. Right here. And then how many of those go even odd? Well, this one does, and this one does, and this one, and this one. So we have 4 out of 16, or 1/4.